Alright, in the last video we looked at how to derive the sine sum and the cosine sum formulas. And here I've got the sine sum copied down. We'll look at cosine in a little bit. But the sine sum formula says that we take, for the sum of two angles, we take the sine of the first angle times the cosine of the second angle, and we add to that the sine of the second angle times the cosine of the first angle. Now, what we want to look at is how does that change if we're trying to look at a difference? What if it were the sine of the quantity A minus B? Well, that's as simple as substituting in place of this B, the opposite of B. So where we have the sine of the quantity A plus B, this is now going to become the sine of the quantity A plus the opposite of B. So anywhere that we had a B before, we're now replacing it with the opposite of B. So with that in mind, this right side becomes the sine of A, that one's going to stay the way it is, times the cosine of, and remember we said this is where we substitute the opposite of B, plus the sine of the opposite of B, times the cosine of angle A. Okay, so on this left side then, we can do a little simplifying. Rather than writing it as A plus the opposite of B, we would typically write that as the quantity A minus B. When it comes to the right side, now we need to recall our odd and even identities. Remember, cosine is an even function, and sine is an odd function, which means that the cosine of the opposite of B, the cosine of a negative angle measure, is equal to the cosine of the corresponding positive angle measure. So here this sine of A is going to stay the way it is, and the cosine of the opposite of B is simply equal to the cosine of B. Sine, however, is odd, which means the sine of the opposite of an angle measure is equal to the opposite of the sine of the angle with the same measure but in the positive. So for example, the sine of negative pi over 3 is the opposite of the sine of positive pi over 3. So what that's going to do here is, because it's going to become the opposite of this plus sign is now going to change to a minus sign and become minus sine B times the cosine of A. So notice what change that made. Whenever we change our sum into a difference, note that we have still the same sine A, the same cosine B. Here the sine B cosine A is the same, but what changes is this plus becomes a minus. And this represents, in this last line, this is our sine difference formula. Now, typically in our book, they're going to write the sine sum and the sine difference identities as one identity. And the way that we'll see that is they'll say the sine of A plus or minus B is equal to the sine of A times the cosine of B. Here where it was a plus, that's a plus. Where it's a minus, this is a minus. So there again, we get our plus or minus, sine B cosine A. And that represents then the sum and difference identities for sine. Okay, so now let's look at a cosine function. The cosine sum that we had from the previous video, the cosine of the quantity A plus B is equal to the product of the two cosines, cosine A times the cosine of B, minus the product of the sines, sine A, sine B. There again, let's do some substitution. So we'll replace that B with the opposite of B. And we'll do that on the right side as well. opposite b in that case, minus the sine of A times the sine of opposite b. Okay, so the same types of changes occur. On this left side, we simplify our double signs down to an A minus B. And on the right side, we're looking at our odd even again. So here, remember, cosine is even, which means there is no change in the positive or negative value there. There again, the sine of opposite b becomes the opposite of the sine of b, which means this minus sign is now going to become a plus, sine A, sine B. And that represents our cosine difference formula. Just like with the sine formula, you're going to find that in our book they're going to condense them down into one identity. So let's look at what we have in common or what's different. Here we have a sum A plus B, there are A minus B. As we look at the first term, cosine A, cosine B remains the same. Likewise, that second term, sine A and sine B, the product's still the same, but what's changing is this minus now becomes a plus. So when we condense these two together, the cosine of A plus or minus B is equal to the product of the cosines, cosine A, cosine B. Now we have to be cautious, because whenever we have a sum for cosine, it becomes a difference. So there, opposite this plus sign, we have a minus. Whereas when it's a subtraction of two values, the difference becomes a sum. So rather than here where we have the cosine of A plus or minus B, and the right side when it's in an expanded form, it's going to be minus or plus, indicating that you have to remember to change the sign of the symbol. Whether it's plus, it's going to become a minus, and if it's a minus, it's going to become a plus. And that represents then both of the cosine sum and difference identities in the terms of how our book will have them written. So at this point, we've identified then 4 of the 6 sum and difference identities. The ones that we have left are the tangent identities. So let's take a moment and look at those. Now, one of the things that we have to be able to recall is that the tangent of any angle is equal to the sine of the angle divided by the cosine of the angle. So in that case, let's look at the tangent of the quantity A plus B. So if we think of that as the sine of the angle, A plus B, divided by the cosine of the angle, A plus B, then we could just leave it in that form. If we know the sine of the sum or the cosine of the sum, we can simply find it that way. But there is another way that we can do that, and to look at that, we need to look at these in their expanded form. So the sine of A plus B, as we just described, is the sine of the first angle times the cosine of the second angle, plus the sine of the second angle times the cosine of the first. On the bottom, our cosine expanded. Take the product of the two cosines, cosine A, cosine B. Change that plus to a minus, and then the product of the sines, sine A, sine B. Okay, so you might look at that and think, well, that's not any simpler than the one that we just had in this step. And you're right, it's not. It's a little more in an expanded form. But the thing that's different is here I was having to know the sine of the sum. In this case, I need to know the sine of the individual angle, the cosine, likewise the sine of A, the sine of, where is that? Sine of A, sine of B, cosine of A, cosine of B. If I know those 4 values, then I can substitute into this formula. But let's make another change, and this change is going to seem a bit odd for the moment, but you'll see where it's headed. So I want to multiply both the numerator and denominator, this whole quantity. I'm going to multiply by the secant of A times the secant of B. And we'll do that both in the numerator and the denominator. So in effect, what we're doing here is we're multiplying by 1. And we know that that's a legal move in terms of mathematics. Okay, so what we're going to then do is distribute that secant A, secant B across the numerator and the denominator. Now in this case, when I try to multiply this first term, sine A cosine B, times secant A secant B, we know that this cosine B and this secant B are going to cancel each other out because they're reciprocals. When we multiply them together, they become a 1. So what we'd be left with is the sine of A times the secant of A. Plus, we're going to do the same thing here. Now notice in this case, the cosine of A and the secant of A, they're reciprocals, so those two multiplied together are going to produce a 1. So what we'd be left with in that case would be the sine of B times the secant of B. Now let's discuss that denominator. Now in the case of this first term in the denominator, whenever you multiply the cosine of A times the secant of A, those two are reciprocal, so they become 1. Likewise for the cosine of B times the secant of B, which means in this case this first term simply becomes a 1 minus. Now in the case of the second, there isn't anything that's going to cancel. There's no cosines in this second term that would cancel either of the secants. So here I'm just going to rearrange terms. Got the sine of A times the secant of A times the sine of B secant of B. Okay, so let's take a little side jaunt here for a minute. I want you to consider what's going on when you multiply a sine of an angle times the secant of the same angle. So, side note, the sine of angle A times the secant of angle A. We know that the secant is the reciprocal of cosine, which means this is the same as 1 over the cosine of A. When I multiply that by that sine of angle A, in effect what we're creating is the sine of A over the cosine of A. And we know that the sine of an angle divided by the cosine of the angle is the same as the tangent of the angle. So what we've done here with this sine A and secant A is we've created the tangent of A. Plus, in this case, the sine of B times the secant of B would be the tangent of B. In our denominator, 1 minus sine A secant A becomes tangent A, and sine B secant B is the tangent of B. And this produces another form of then the tangent sum. So we could do the sine of the sum over the cosine of the sum. We could do it in their expanded form as we did here in the second step, or we could do it in this form. So the tangent sum is equal to this quantity. Now notice what's going on. It's the tangent of the first angle plus, so keeping this symbol, times the tangent of the second angle. In the denominator, it's 1 minus, and that's always going to be the opposite of whatever we have here is what we'll have in the denominator, the product of the two tangents. Now, if we were to substitute an opposite of B into that formula, then what that's going to do, the tangent of A plus the opposite of B, tangent, like sine, is odd. So in this case, where we substituted in that opposite of B, and then use our odd-even identities, because this is an odd function, that plus is going to become a minus. And likewise in the denominator, this minus, because of this odd tangent of opposite B, become plus. So what's going to end up happening is that whatever symbol we have in this position will have the same symbol in the numerator, so a minus and a minus, but the opposite sign in the denominator. Now the way that we condense that is by saying the tangent of A plus or minus B is equal to the tangent of A plus or minus the tangent of B over 1 minus or plus tangent A times tangent B.